My name is Brian Grenon. I've been involved in the photomask industry for over 35 years. I was responsible for mask development at IBM for years, and 15 years a consultant in the photomask industry. And last year I've been working with RAVE LLC on technical development. The challenges that we face today are significantly greater than they have been in the past, particularly in the fact that it requires more financing. So the cost of participating in the semiconductor industry has significantly increased over the years. And kind of what I call it is economic Darwinism, and that the more expensive it gets to play in the game, the fewer players there are. And that's one of the drivers in increasing costs for equipment and processes. But in reality, one of the things that, if you look at this advanced lithography symposium, it's really a testimony to the inventiveness and ingenuity of the litho engineers. Not to take anything away from the equipment manufacturers, because they've done an excellent job, but the litho engineers always seem to find special ways and tricks to extend the technology. What it requires people to do is focus more on the issues. So it's, in the past, when it wasn't so expensive to play in the game, you could look at a lot of different technologies and a lot of different solutions. But now that the costs continue to rise, there needs to be, and there is, continued, more intense focus on solving the issues at hand. If you look at EUV, there's been significant improvements and significant advancements. However, there are still the challenges. The challenges remain source power and mask infrastructure. So in final analysis, that's what it always comes down to. If you look at, for example, imprint technology, as you probably saw in the last month or so, that they demonstrated patterning on 450 millimeter wafers, which was a tremendous advancement. We see also a continued emphasis on directed self-assembly, which is making significant progress. But a couple other things that have actually come in, and also direct write e-beam. If you look at e-beam development, for example, there's been significant improvement and significant advancement in mask pattern generation with multi-beam, which is definitely needed to reduce or to abate the cost of mask making. And there is some definite promise in direct write e-beam. And part of the issue with direct write e-beam, everyone thinks, there's a mentality in some cases where people think it's going to be, or feel that if it's not going to be a ubiquitous solution to lithography, that it really shouldn't be considered. But there's definitely a place in direct write e-beam, particularly when you start talking about triple and quadruple patterning. Some of those levels or some of the part of that design could definitely be effectively written with direct write e-beam. But two of the other issues that seem to be arising is also 450 millimeter wafers. If you looked at 2 or 3 years ago, or maybe 5 years ago, when people brought up 450 millimeter wafers, it was people would say this is insanity, but it's actually coming to fruition. There's been tremendous progress made in 450 millimeter. And the other one that seems to be raising its ugly head is 9-inch glass masks, which I feel, even though it's, every 10 years it comes up that we need to look at 9-inch masks. Problem with 9-inch masks is it's going to be prohibitive costs. And what I would think is that if you're going to get into 9-inch masks, you're going to have to completely retool the mask shops, because most of the equipment isn't retrofittable. So you start to get into the realm of $1 billion mask shop. And the question becomes, how many people can really afford that? It would require hundreds of millions of dollars in development costs, both for the equipment manufacturers and also for the mask makers. From a mask standpoint, getting tighter mask specifications and also write time and throughput on a pattern generator. So I think the fact that you see in the horizon an effective solution to multi-beam pattern generation for mask making, I think is going to significantly reduce some of those challenges. But mask costs are still a major issue. The major cost in in a photomask is the pattern generation time as well as the inspection time, and inspection technologies moving forward as well. Reaching the next node, I think the foundation for doing that is in place. I think if you attend a lot of the papers here today or this week, which I've attended, show that there are a lot of development plans, a lot of progress toward meeting those requirements of 193, 193I with improved OPC, improved mask specifications, even though it may be a little more expensive. But I think the engineering is there. So I don't think it requires a tremendous amount of new science or doing the science. I think the science is well understood, and I think the engineering plans are in place to meet that technology node. The next node after that remains to be seen. I think it's going to be. I think would be determined on how well EUV advances over the next 12 to 18 months. You still have the skeptics, and I might be considered a skeptic in some of the areas of lithography, but I think if you look at what the mood was 2 years ago, it was really down. And last year became really upbeat, and I see the same increase in optimism this year. I think the major thing that's contributing to it is the improvement in some of the, or solving some of the problems associated with EUV. And I think there's come to a realization that 193I is going to be around for a long time. And people have come forward with a lot of the solutions that are required to keep that technology in place.